So today we're going to start with our interactive petrophysics tutorial. So let me just close off this. So for the purposes of the recording, we can have all steps. So the first thing we want to do to open interactive petrophysics is to type IP in the search bar and click to open. We have a pop-up, we just close that and we expand. And we like to import our well log data. So we go to import, export, and we go to import. And the type of well log we have is called a LAS file. So we're going to click on LAS. And I will have sent you a file for example. So let's see example2.ls and click open. Okay, all the logs that are in our file. So we have that alpha, rho B, which is our density, neutrons, spontaneous potential, gamma ray, deep resistivity, shallow resistivity, permeability, porosity, etc. Right? So we want to make sure that all our logs are loaded. So you'll see that you have a tick, so just put a tick on it. We also see if you want to change anything on the well, you can change it here. Deborah as well. We also see that this well log was run from a top depth of 7,614 and the bottom depth of 8,736 feet, because that is in feet here. And now to the side, I want you to scroll down and click on load. And you should see at the bottom here, you'll see your file is loaded. You'll see a little in red, right? So once the file is loaded, you're gonna click close. And we're gonna open up our well logs now. So we're gonna go to view and click on database browser to bring up our tree view. And we should see Deborah as well here. And you wanna click on the arrow. And click on log plots. And click on IP defaults. And what we want to do is to bring up 3 blank tracks, because I want to show you all how to load your wells on blank tracks, right? So double click on 3 tracks blank. So here IP will have automatically loaded the depth of our well, and if we move our mouse across point we put on to the bottom, we can reach the depth that we're on. And we have 3 blank tracks. So on the first track, we wanna load up. Wait, what is the first track we usually do? Gamma ray, right? And a color. So to do that, we're gonna double click on one. And here we're gonna click on the first row, and we're gonna select a gamma ray, which is called SGR in this case. We also want to click on the second one and bring up our caliper, which is CLI. And if you just click anywhere, you would see that IP has automatically placed the scale and colors for our well logs, right? You could always change the colors here, but for now we're gonna leave it on the default. And we're gonna click apply and OK. Everyone seeing your gamma ray and caliper? Jimmy? Okay. So the second track we're gonna load our resistivity logs, right? So we're gonna double click on track 2. And similar to what we did before, we're gonna load our resistivity logs, and in this case it's called LLD, which is lateral log lead, and then LLS, which is lateral log shallow, right? And when you all do reservoir evaluation, I think it's what it goes, no, formation evaluation, you learn about the different types of resistivity logs, right? And measures, the formation one measures around the elbow, those kind of things. We're gonna click apply and OK. And to the track, we're gonna bring up our we should bring here. Yeah, density neutron, right? So our density is rho B, and our neutron is T N E P H, right? And we're gonna click apply and OK. So one thing you'll notice is here we have some of the being cut off. So if we just scroll, you'll see that you can drag it down to see your headers better. We see that gamma rays in API units, caliper log is in inches. What does the caliper log measure? Yeah, the diameter of the hole, right? So if we look at the beginning here, we see that this the whole size here is bigger than the rest. If you all can see that, you're seeing that Aditi, right? So in the beginning here, we see that the whole size is bigger. So that could be a possible washout, right? So this is things you want to look for. We see high resistivity here. So what are we expecting in this area again? Correct. And where we have low resistivity, what you expect? Right. So if we go to scale and we click on 1,000, we can expand our graph. And if you scroll down, what you can notice also to the extreme right, you see 2 red lines here. This will show you where in the log you are located. So you scroll, let's just say go to extreme 100. You can see we are on this section of the log, right? So we're going back to full. Everybody on the same page, right? Jamie on the same page? Okay, good. So what we're going to do in this well log is to do an interpretation. So we're gonna click on interpretation, and we're gonna do today we're gonna learn to do 3 different interpretations. So we're gonna calculate plate volume, we're gonna calculate porosity and water saturation, and we're also gonna look at some cutoff and summation parameters. So the first one we're gonna look at is to calculate plate volume. So in formation evaluation class, we will learn how to calculate clay volume manually, right? So we're gonna learn how to calculate clay volume. You can also calculate your shale volume via shale using petrophysics, interactive petrophysics, right? So what we could use is our single play indicators. We're gonna use gamma ray, and we are going to use resistivity. And for our double play indicators, we're going to use density neutron. So again, when you manually, there are more than one way you can calculate clay volume based on, you could use the gamma ray log or you could use the resistivity log, right? So we're going to click run. And now we'll see a clay volume log to the right here. And these three logs that you see here is what was calculated based on the green would represent calculation from the gamma ray. The purple is weakly from the resistivity, and the red shows weakly from the neutron density that you read from the header. And we have the three logs that we selected to calculate our clay volume. So this note that I have here. So since different sand packages have varying degrees of shale content, it would be best for each sand and shale package to have its own minimum and maximum line to represent the sand and shale content. So what this is saying is that this green line represents the maximum average value of shale, and the red line represents the minimum value of shale for clay in this instance, right? And what we want to do is to separate these into different sand packages. And I'll explain what that means. So what we want to do is to split our log based on lithology and hydrocarbon content. So for example, if you right click on the clay volume, which is the second row, we're going to click split zone, and we see that this zone here, and we're going to split it. We identify that this is sand, and we see that this is a possible hydrocarbon zone, and we want to split our log as best as possible into different zones based on lithology, right? So I'm going to give you a few minutes to split your log. So you're gonna look at all three logs to determine how best you would split your log, right? Oh. So you're gonna understand how to split it. So you look at what I said. Okay, let's go and share this one. Yes, so I was saying that sometimes you want to zoom in to put your lines, a little more accurate. Right. So like for example, you see here it's kind of off, so I just move it up a little bit to separate. Okay, so now that we have our source, everybody have the source. So remember to also look at the Neutron density. Where Ruby is to the right, we expect to see this is typical shale. We have shale here. So everybody completed that on 18. All right. So what we want to do in order to have our volume of play accurate, we want to use the maximum and minimum lines to indicate the maximum and minimum of our gamma ray here, right? So the green is our, let's start with zone 2, right? So the green is our maximum line, so we want to move it close to where we have our highest point, and we want to move the minimum line to where we have majority of our minimum or lowest points, right? So we want to move each one of these zones to represent the maximum, average, maximum, and minimum points. Now, another way we could do this is if you right click on the gamma ray log, I want you all to click on HGR histogram. And here we see the number of points. And here is the axis for GR, right? So we have 0 to 150. We also see mean, mode. And we can move these lines again. So where we have majority at the points to represent maximum and minimum. So this is for zone 2. And if we want to move to zone 3, we click on the box here. Right, so you could also use this histogram tool to represent where you have the majority of your maximum points and your minimum points. Everybody understand that? So for those who missed this part, just click this on X button. We right click on the gamma ray and we click on gamma ray histogram. And to see zone, we click on the box. If the box is highlighted, so you see this box is highlighted here by the don't tick, we are not moved. The lines that we see here is the line for zone 1, right? We have to make sure that it's both highlighted and you have to be working on soon. So, for example, here, I can move my minimum line across here since it's the average. And I can put this here. And then if I click close, I expect the lines move here, right? So you could do it manually like this, or you could also look at the histogram. Everybody is at this point where they would have moved their maximum minimum line. So the next step is to also you move our maximum and minimum lines for resistivity. So we're gonna right click, and go to LLD histogram. And what you'll notice for the resistivity, we don't have much points on this side here, right? So we won't really be required to move the green line. We're more focusing on the red line, which is our minimum line, right? Or maximum line in this case. So let's put this into the C4. Gonna move this line over 30 points. We're moving up maximum line. For each episode. So the reason why we have a maximum and minimum line is this is the software will use it to calculate the volume of clear, right? Then your calculation. And if you all remember, when you do manual calculations, you usually use a GR max and a GR min. So here we're telling the software what's the maximum or minimum based on average number of points. Okay, close. And what we could, the next one we want to move on is our neutron density, right? And just to mention, if it is that you point at anywhere on this curve to the bottom, you could read the depth and the values for your neutron density, right? So to the bottom of the screen here, you'll see the values that you can read the values that you're pointing to at that particular depth. So at this particular depth, the gamma ray is 29. So for neutron density, because it's too close, we use what is called a crossplot. So if we right click on it, click on the neutron density crossplot or X-plot, and this will bring up our neutron density crossplot. So the first zone was really a washout zone, so we're not really going to focus on that. So we're going to go to the second zone. So we're gonna check out the first one and click on the second one. And we can see that this curve is our density on the y and our neutron on the x. And what we notice is that not all of the points are encompassed within our graph, right? So the graph is reading within here. So we want to do is right points. You see x, and we want to encompass all the points like so. I'm gonna do that for each one of these zones. And of course, these points would be our neutron density points on our graph. So once we finish encompass all the points, our volume of clay graph should look similar to this. I'll just give you a few minutes to make sure everybody has completed all the zones. Interpretation we like to do. We go to interpretation. We want to get our porosity and water saturation levels. So we click porosity and water saturation. And here IP selects, we have different input curves that you can see here. But what I want to focus on is our porosity model. So we could choose different models to calculate our porosity, right? So we have neutron density, density sonic, density alone, neutron alone, sonic, or pass through. So sometimes you might not have what the well logs available here, and you might have to use the one that is available to you, right? But in our example, we have both density and neutrons. We're gonna keep the equal, and we also have our saturation or water saturation equation. So we have different ones that should be familiar to you, such as Archie, Simandu, Indonesian, and the water saturation equation it uses based on the type of water RW water calculates, right? So for this example, we're gonna click Indonesian. We also want to select our temperature units. We're gonna leave it in Fahrenheit. So far, the only thing that we would have changed would be the saturation equation being Indonesia. So from here, we're gonna click OK. Now that we know the interactive petrophysics, which equations to use, and you'll see a pop-up asking if to link your play volumes and your porosity water saturation. So you want to click on to enable it to the play volumes that we would have created in the previous step. We're going to click OK, and the software process to enter temperature curves. We're going to click yes. So at a depth of 0, we have a temperature of 60 Fahrenheit. And we'll also place one more, which is 86,000 feet. We have a temperature of 140 degrees. We're going to click on run. 86,000. Sorry. Well, 8,600. And then 140 for the temperature, right? You click on run and close. And then we can click OK. Now it asks if we would like to see our water, saturation and our porosity. So we click yes. And we should see a bunch of logs popping up, right? So in the Word document that I would have sent you, there's what the abbreviation for each of the different logs, right? So we have ABB represent apparent multitude resistivity. So the first one will be our gamma ray. We have our porosity input, which would be the total porosity that was calculated from the equation that we would have selected. If we also click and drag down our mouse, we can see that some other hint was hidden. Yeah. And on the same page. So, like I was saying, if you drag down the header here, but you can see some additional things that are hidden, right? Of course, we have the porosity that was just calculated. I want you all to right click on lithology and click on shading, and you can see the different lithology types based on shading. So you have sandstone, soil. Let's see, I have a question. Okay, so I would have said to right click by my mistake. I mean left click on the heading, and you'll see the log plot format. We have the different curves that on shading. We could see our lithology and what the different shading represents. Sandstone, silt, etc. So we can close off the clay. So we're gonna close off this. We can also see our apparent water resistivity, apparent filtrate resistivity. We have our saturation, and we have our total porosity, effective porosity that would have been calculated from a porosity input on the left over here, right? So the porosity inputs that we would have selected would be neutron density. And based on that, we have this software would have calculated total and effective porosity. So at this point, I don't know why I print these notes so small. So at this point, I want you all to right click on the apparent water resistivity log, which is under salinity. And we're gonna look at the apparent water resistivity histogram. And here, what we want to do is to move the baseline and drag it across the peak for all these ones, right? So to select all these ones at once, we're gonna click on all zones. And we're gonna take our baseline and move it on our peak, which is the most point. And we're gonna close up this window. And now the green line should line up with our apparent water resistivity in the water zones. So our RW apparent, which is our green graph here, in the water zones, our green line should line up with that curve. So in my log, you would see that my water zone to be zone 3 because my green line is lined up with this log. And also we see some resistivity, some water resistivity in my zone 6 here, right? So everyone understands that? Okay. So the next thing we want to look at is our LLD-phi crossplot. So I think Sarah, you got your, you're able to move it across the peak. So we're gonna look at our Pickett plot. So we're gonna right click on our resistivity plot LLD. And we're gonna select our LLD phi E crossplot, which is also known as the Pickett plot, right? So what the Pickett plot is a log plot of a resistivity measurement on the x-axis versus a porosity measurement on the y-axis. So we see we have lateral log the resistivity on the x and phi E on the y. So slopes of constant water saturation will be plotted where the bottommost line has a water saturation of 1. So let's look at our water zones, and again mine is zone 3 and within 5, no, not 5, 6, zone 3 and 6. And what we'll see is that our bottommost line, most of the points would be going through there, right? And if I click on another zone, for example, let's see zone 2. So for example, zone 2 we see it's scattered. That's because it's not our water zone, right? So basically the bottommost line, our water zone should line up with the bottommost line. So for this tutorial, everything is good. And we're gonna click close. And information evaluation, you all will learn how to do the plot of Pickett plot from scratch. And yeah, how to calculate it. So the last part would be to do our interpretation and cutoff. So we're going to go to interpretation and go to cutoff and summation. So here we want to use which curves to calculate our net pay. So we have porosity, water saturation, and volume, yes. Oh, you got stuff. So what's the last thing you have? Right. So the LLD phi, we don't have to change anything in it. We're just looking at water zones. And the next thing would be to go to interpretation and cutoff and summation. So no, yeah. So here we're gonna choose which calculation or logs we're gonna use for our net pay. So we're gonna use porosity, water saturation, and we also want to see the output of our clay volume. So click on clay volume. So we're gonna use these curves, and we also wanted output. So we're gonna click on run. So this access, if we want to use the porosity and water saturation that we would have previously calculated, we click yes. And you should have something similar to this where you're seeing a play flag and a reservoir flag. Everyone is seeing this? That's okay, but showing the whole thing as reservoir, right? So what you want to do is to define your porosity. You want to apply some cutoffs. So for example, if your company says you want 20% porosity cutoff on 45% water saturation, we're gonna go to interpretation. We're gonna go to cutoff and summation parameters. We're going to go to the reservoir cutoff tab. I'm just gonna expand it a bit. And I want you all to put for porosity, gonna use 20%, so we put in 0.2, and we wanna place 0.2 for all these zones. And the porosity cutoff for your reservoir. And your water saturation, we're gonna put a value of 0.45 to represent 45% for all zones. And once you've done that, you want to click on run. And you see that your reservoir and your paved flats will be smaller, right? So you click close and see if that improves your results. Yeah? Okay, so what we could see here is that our hydrocarbon zones are in zone 2 and 5 in my own. So we could delete all the rest of the zones since we're not interested in it. So we just right click on delete zone. And we're just gonna leave our hydrocarbon zones, right? And to see our peer results, we're gonna go on again, we're gonna go back to interpretation and we're gonna go to cutoff and summation parameters. And the last two tabs show us our results, right? So we go to reservoir results and we should have two zones because we have two hydrocarbon zones. And these are the results that we would use when we're calculating our original oil in place, right? Or original gas in place formula. So remember the 4, 5. What's the number for somebody to calculate gas in place? What's the gas in place formula? 4, 3, 5, 6. You want to know this by heart? Okay, what's the oil in place formula? Right, 7,758 area by height by porosity by 1 minus SW. And what's the number for gas? Right, 4, 3, 5, 6, 0, right? So when we use the 4, 3, 5, 6, 0, and we using area by porosity, this is where we get our porosity values, right? So here, if we go to our peer results, we have our average porosity here, and the 1 minus SW, we have our SW value here, right? And we also have our pH, which is porosity by height. So these are the important results that you need for your calculation of original oil in place and original gas in place when you're doing your reservoir evaluation, right? So it also shows you the gross interval, the net to gross ratio, and your, but it's pretty explanatory, everything here, right? So if you want to save this, you click on print, normal report, file. You can name your file, the browse well results, and click save. Make sure and save it on your software session, and click save. They might ask you if you want to do it. Let's click on yes, and here you would see all your results, right? Another useful thing to know, close of this, is if we click on the cascade window here to the bottom right, we could see all the logs that we would have created. So let's say, for example, we want to put this log in our report. We can click on, I think, print. Yeah, print. And you see this page coming up here. You browse where you want to save it. But the computer is just moving a little slow right now. So let's save mine on my desktop in the August software session. I'm going to name mine well log porosity. Save. And you could scroll down and click OK. Do you want to view your graphics? Yes. So here you have a nice PDF map that you can put in your report, right? And if you don't want the heading on the, if you notice you have the heading on the top and the bottom, you could always remove the heading front, bottom, front case at bottom, no. So you could always look through this window to customize how you want the PDF to be downloaded. If you only want, say you want a specific section of your log, you can type in the top and the bottom that you want of your log, like that section, and download it. So you can have nice log graphs for your reports and whatnot. So that's it. Any question?